Alright, let's keep on doing intervals. So I think I have tried this before, but it's been a while, and I don't think I completed it last time. Also, I just tried to do this one, but I couldn't figure out the solution, so I'm gonna go back here. Okay, you're given an array of non-overlapping intervals where intervals I equals start I and I represent the start and the end of the ith interval, and intervals is sorted in ascending order by start I. You are also given an interval, new interval, start end, that represents the start and end of another interval. Insert new interval into intervals such that intervals is sorted in ascending order by start I, and intervals still does not have any overlapping intervals. Merge overlapping intervals if necessary. Return intervals after. Okay. So two things we need to do: insert, and then make sure that there's no overlap. Okay, so it's already sorted. Okay. So we're given a number line. So if there's a number line, we're given an array like this. And basically, we need to insert our number in like where it is. So like if this is a 5 and this is a 9 and ours is a, we have to insert a 6, then we would have to, if our thing is a 6 to like an 8, then we would have to insert it here. Now, if it's a, for example, a 5, then we would have to merge it. So there are a few things we need to think about. Okay, so list already sorted. So I'm thinking we can just start by iterating at the start until a number becomes greater than our thing here. Iterate until we find interval that is greater than our new interval start. Add to new list. So like as we iterate, we just add it to this new list until we find something, until we find this one, until we find this one, and then we don't add. So then at new, so then once we're here, we're gonna say if the start is what's it called? If the start is equal, wait, what happens if it's equal? Okay, if the start of this does not overlap, which we'll figure it out, like specifically what that means, then we just insert it. If it does overlap, then we edit this. um, we edit this to extend here, and then we then check the end of this. If this overlaps, so add new interval to a new interval to list, and then we need to check the end. So if the end does not overlap, if new interval end does not overlap, append the rest of the list. If it does, then you must change this to either connect with the current like last thing in the new array, right? So either we extend this if it's all in one, or like if originally we only extended it here, then we would have to continue it, or if we just insert a new one, we would have to extend it even more. All right. If new interval does not overlap, append the rest of the list. If does, change end of last interval to last of the end of the next interval. Okay. Overlapping. Alright, it's slightly confusing, but let's just go through it. So iterate until okay, so for I in intervals, for interval in intervals, if interval 0 is smaller than new interval 0, we're going to also create a new list. New, I'm going to just have a result list. If interval 0 is smaller than new interval 0, then we say result dot append interval. Else, I think we can just continue here, right? Continue. If it doesn't, then if it is not smaller, so like basically what happened at this point is, so this is like, so we had something like this, we had something like this, we had something like this. So So this is smaller, we added it. This is smaller, we added it. Now it's not smaller. So now we add the 5 to the 8. So it can either be not touching, or it can be touching, right? So so we say if interval maybe we should have an added, right? Added equals 0. We can say like if added equals 1, then we just continue result.append interval and then continue. You can have something like that, right? It's like if we already added our interval completely, just keep going. Okay, so if interval 1, now we're comparing, because now we saw that this one is greater, right? So if interval 1 is smaller than, or I guess greater, we're talking about interval 1. If interval 1 is greater than new interval, and this should be 0. If interval 0 is greater, oh, one more thing. So now, okay, so this one's greater. We also need to check if the end of this one overlaps. So we need to check that first. So if result -1, if result -1, 1. So we're saying if this one is greater, like depending on if this overlaps, we just like add whichever, right? So if result -1, 1, if it's smaller, so I'm thinking like the best thing we can do is we can say, because we don't know, because another thing is that our interval can cross through multiple, right? Like our interval can actually fit like here and then cross through many, and then we would have to just have one. So we can say if result -1, 1 is smaller than new interval 0, then result dot append new interval. Now we're adding the new interval, right? And okay. So we need to, okay, so that'll add this. And then, okay, we need to do something. But the next thing is if I guess, okay, we can just say else interval result -1 1 equals new interval 1, right? And we're just saying if it does overlap, right? If it is this, then we would want to turn this into into this, right? Okay. So I think we should have two states. And now we need to check the end. So if new interval 1 is smaller than interval 0, if it's smaller than this new one, right? Because right now we're at the point where the new interval is smaller than the current interval. If it's smaller than current, so we're saying if the 1 is smaller than this one, then we continue. And we say added equals 2 or something, right? Then we just continue forever. Or else we say if interval 1 is greater than if new interval 1 is greater than interval 0, then we say result -1 1 equals interval 1. So if this one also overlaps, then we want to continue this one. And then same thing, like if it's like this, right? Wait. Yeah. Okay. And then we say added equals 1. Okay, it is a lot to keep track of. So the simplest one is just, if added equals 2, then we just append interval. And if so there's, right now we have 3 states. One where we're just adding until the end. Number 2, if the interval of the interval 0 is smaller than u interval 0, okay. And then the third, where when the interval that we're at is bigger than u interval, but there might be like overlap, or it's like the first time there's no overlap. Okay, so we just have to, let me just like clear this up and make it more simple. So we can either have something like this, and make this smaller. So either our new interval can be like this, either our new interval can be like this, or it can be like like this, or it could even be like this, where it extends further than the last one, right? So, so if this one's smaller, then it doesn't matter. We just add it, because that means we haven't reached the place to insert this yet. But if it's not, if result -1, 1 is smaller than new interval, first of all, I guess we should say added equals 0 here. I don't actually know. Let me think if we actually need that. If result, if what we have so far, if the 1 is smaller than new interval. Yeah, so we don't actually need this, right? But if, also I need to check. I still don't know if the intervals can actually overlap or not. Four to 8, okay, so they can't overlap. So if interval 0 is smaller, okay, that's good. If result -1 is smaller, that's good. It has to be smaller, it can't be equal. You wouldn't append it if it was equal. Else results -1 equals new interval. Okay. This will, so this part, this will only occur on the first first time new interval new interval 0 is smaller than interval 0. Okay. So every other time we should also have maybe a elif. Result -1 is smaller than new interval. if result -1 is smaller. So what happens if result -1 becomes greater? So we say elif added equals 1. So this is when we merge, but so this is when we merged. But at some point, this thing can be bigger, right? So we have, so in our results here, result 1. What is result 1? So when we're here, we're automatically going to we're gonna add this until here, and then we create our new thing, right? So this is our new interval. And let's say we use red. If we're here, so now this is results -1. So if result -1 is greater than new interval, if result -1, if result -1 is smaller than new interval 0, then you append. Because this time we're comparing this one. Elif added equals 1. So when we add the new interval, we say added equals 1. And now we say, so now it's been added, and we're just trying to compare the interval 1 to the result -1. So if interval 0 is greater than new interval 1, we should probably have result. I'm thinking, yeah. If result -1 is smaller than interval 0, then we must append, right? Result dot append interval continue. Or else, if it's not, then we keep it like that. And it's not here that we do that yet, it's right there. And at the very end, we return result. Okay. So Okay, let's rethink the logic. If added equals 2, basically, if at some point result is smaller than the interval 0 after we already added our new interval, then okay, if added equals 2, result out append. Okay, if interval 0 is smaller than new interval, then we add interval, right? There's no situation where that wouldn't be the case. So now we're at the next one. If result negative, so now we're at interval 0 is greater or equal to new interval 0. So now we're at this one where it's greater. So now we say if result negative 1 is smaller than new interval, if this is smaller than new interval, then we just append this. Then result dot append. Okay, that's good. Or else elif added equals 1. Wait a minute. Maybe this should be 0. What else can this be right now? Do we even need this added equals 1? Yeah, we don't. Elif, maybe it should be added equals 0. Result negative 1 new interval. Yeah. Elif added equals 0. Then we do it. Or else, we just, everything else here added equals 1, right? So if result negative 1 is smaller than interval 0, so interval here now, if result 1, then we append interval. Continue. But if new interval whoa, what's going on here? If result negative 1 is smaller than, what do we do else? What happens when result negative 1 is greater or equal? What happens if it's greater or equal? Else elif result. So we're saying if this one is, if it's smaller, if result negative 1 is smaller than interval 1, result equals interval 1, right? We're saying if interval 1, if it extends past, right, if interval 1 is greater, then we make this interval 1. Or else, if not, then we just keep it, right? If this one's greater, then we just keep it. And we just say added equals 2. Can we say that? And here we would say continue, right? We don't even need that, I think. Okay, I think we got something close. 2, 5. Okay. What's going on? Output. Okay, so something related to if result -1 is smaller, then we append. When have we, if result -1 smaller than interval 1, no, that shouldn't cause any issues. If result -1 is smaller than new interval if result, what happened here again? So in this test case, the number that we added, 4, 8, it combined with 3, 8, and this, but it should combine with this. So it should be around here, right? If result -1 is smaller than interval 1. If result could it be this? If result -1, if result -1 is smaller than interval 1. Okay, I think, yeah. If result -1 is smaller than interval 1, if result is smaller, or it's equal. I actually, I don't know if that will make a difference, will it? I don't think it will. Yeah. If interval 0, if result -1, 1 is smaller than interval 0, result alright, I kind of looked at it a little bit. I think what we can do instead is, for this one, we can just say if interval 0 is greater than new interval interval 1, we can say if added equals 0, then result dot append new interval. So this is going to be the first time we actually encounter it, and then we set added equals 1, and then in both times we say result dot append interval, and then elif this, and then the else will make it much more simple. So this is the case if current interval is fully after, right? This is if interval comes before. And then now we can say else. This is when it overlaps, right? So in the first scenario, we have this number line. We're saying if interval 0 is greater than our interval, so this is our interval that we're trying to insert. If it's fully greater, then we just add this one first. We add this one. And then we're saying elif interval 0 is smaller than new interval, then we append interval as well. Because in this case, interval 0 will obviously not be smaller. Else, otherwise, interval 0 is either right now there's some overlap of some sort, right? Right now interval 0 is either greater or equal to new interval 0, and interval 1 and interval 0 is either smaller or equal to new interval 1. So for this last case, new interval is either greater than new interval 1 if interval 0 smaller. So interval 0 is smaller or equal. So interval 0 could be here. No. Okay, wait. Let's just like let me just like redraw this real quick. Where can interval 0 be? Greater than interval 1. Sorry, new interval 1 can be greater than interval 0. Can be smaller or equal to interval 0. It can be smaller or equal to interval 0. Smaller or equal to interval 0. interval 0 can also be new interval 0 can also be greater or equal to interval 0, so while being greater or equal. Oh my god, this is okay, let me just redraw this. If interval 0 is greater than new interval 1, so if this is our current, let's say this is our interval, what is new interval? Okay, we're just saying it's like that. If it's like that, then we append this first. Or else, if interval 0 is smaller than new interval 0, so right now in the else it's somewhere here, right? And we're saying if interval 0 is small, if new interval 0 is smaller, then should this be 1? Interval 1? Even if interval 1 is smaller. We're saying that, right? Else. Okay. So we're saying okay, now there's overlap, right? Now we're saying if interval okay, so now there's some overlap somewhere. So you can say if interval 0 is greater, no, is smaller than new interval 0, then we say new interval 0 equals interval 0, and we say if interval 1 is greater than new interval 1, then new interval 1 equals interval 1. So this is accounting for the case where they are inside. It can either be this and this. So we're saying if this overlaps but it's longer, then we take the end of this. If this takes the overlap, but this one's longer, then we take the end here. Does that work? Nice. And I think, so at the end, we're gonna have to say result.append interval. So we need to say, so it's basically like if, so we only set it to added if interval 0 is greater than new interval, or if new interval is smaller, but there's a case where new interval 1 is never smaller than interval 0, and in that case there's still the possibility we still would need to add the interval, right? So if added equals 0, would this be new interval? Nice. All right, and this would be, well, it's already sorted. Time complexity is already sorted. So space is O of n. Time is also O of n because we're just going through once, right? We're going through this one and that one and that one. It's going to scale linearly as we increase in size. And let's just check. Yep. All right.